increasing and decreasing functions. If a function's increasing, it's moving up to the right. If it's decreasing, it's moving down to the right. We need to be able to understand that, but also we need to be able to identify intervals over a function where the function is constant, so that means it's not changing, where it's stationary, where it's this new idea of strictly increasing and strictly decreasing. So far we've been able to identify positive and negative gradients. So let's look at an example of that. So here in problem 1, I've got this function, it's a quadratic, it's in turning point form. I know that the turning point occurs at the position 2, 12. And I also know because of the 3, it's positive, that it's an upright parabola. So I've got this basic shape taking place. From that, I need to identify the intervals where the derivative is greater than 0. So that is that the graph has a positive gradient. The derivative is less than 0. The graph has a negative gradient. And I need to identify where the gradient is equal to 0. So therefore, the graph has a turning point. So let's first of all look at where the derivative is greater than 0. So you can see here the turning point occurs at 2. At x equaling 2, the gradient itself will be equal to 0. So therefore, it's going to be positive for all values of x which are greater than 2. Notice that I'm not including the 2. So that's my answer for A. For B, where is the gradient less than 0? So over on the left-hand side of the turning point, the graph goes down towards the right. Therefore, it has a negative gradient. So it's all values less than 2. And then we've got where is the gradient or the derivative equal to 0. And it's at the turning point. It's exactly at x equaling 2. So here we're talking about the gradient, and we understand that from our previous topic. That's just a little refresher. All right. If I were to ask you where is the function strictly increasing, most of you would say that it's from negative infinity going up to x equaling 0, but not including x equaling 0. So that is that x is an element of negative infinity up to 0, not including 0. But we do need to include the 0. So it's obvious that it's increasing here. But why is it that we are including the position 0, 1? Think about it this way. At the position 0, 1, everything to the left-hand side is less than it. So the position 0, 1 is in fact greater than anything else, and therefore it is strictly increasing. So as x gets larger, the values of y are getting larger between negative infinity and x equaling 0, because that position 0, 1 is larger than anything else. We're not talking about the gradient here, okay? We're talking about the values of y. As x gets larger, are the values of y getting larger? And they are, between negative infinity and 0, including that 0. So that's why we come up with strictly increasing. X is an element of the interval negative infinity up to 0, including the 0. Let's take a look at strictly decreasing. Now, the highest value on the right-hand side here is 0, 1. Everything to the right-hand side is less than it. So as x gets larger, y is getting smaller. So it's clear again to us that the position 0, 1 is included in the interval that is strictly decreasing. Again, we're not talking about the gradient. We're talking about as x gets larger, are the values of y getting smaller? And they are, between 0 and 2. The 2 is included because all values immediately to the left of that are greater. So the lowest value that we're going to achieve here is 2, -3, or is achieved at 2, -3. And the highest value is achieved at 0, 1. So everything in between those two endpoints and the endpoints themselves are a part of the interval that is strictly decreasing. So x is an element of 0, 2. Please note that it's very different than when we're talking about the gradient of our function. Strictly increasing, strictly decreasing is different than positive gradient, negative gradient. That's a very important difference. So here in problem 2, we've got ourselves a quadratic in expanded form, and we need to work out the intervals where the gradient is greater than 0, strictly increasing, gradient is less than 0, strictly decreasing, and where the gradient is equal to 0. So the first job is to take that expanded format, use the completing the square method to convert it into turning point form, and then if we graph that, we'll get this shape. So obviously it's all going to be around the turning point 3, negative 22. Part A, where is the y dx, the gradient, greater than 0? The gradient is equal to 0 at x equaling 3. The gradient is greater than 0, that is that it's positive, for all values of x which are greater than 3. So our answer for this is x is greater than 3, or if you like, x is an element of 3 to infinity, circular bracket showing that we can never obtain infinity and that we are not including the 3. B, where is y strictly increasing? Just recall the definition, strictly increasing. As x gets larger, the value of y gets larger. So you can see here that from 3, including the 3, as we move towards the right, so as x gets larger, the values of y are getting larger as well. And that's including x equaling 3. We're not talking about the gradient. So for this one, we're looking at x being greater than or equal to 3. Or if you like, x is an element of the set from 3 to infinity, not including the infinity because we can never reach it, but including the 3, so therefore square bracket. So we're going from that turning point all the way through to infinity. Notice that when x is equal to 3, that is the lowest value that we have. All values to the right are higher than that negative 22. Therefore, the turning point itself is included in the strictly increasing interval. C, where is the y dx less than 0? So where is it that the graph has a negative gradient? And so that's all of these values here up to the turning point, but not including the turning point. At x equaling 3, we'll have a gradient of 0. So the interval that we are looking for C is x being less than 3. So for C, it's x being less than 3. We can write that as being x is an element of negative infinity to 3. And D, where is y strictly decreasing? Take a look at our definition again. Strictly decreasing, as x gets larger, y gets smaller. So if we start over here, you can see that as x gets larger, the values of y are getting smaller. And we get all the way down to our turning point, and we are including the turning point because this turning point is the lowest value that we'll have on the left-hand side. It's the lowest value overall, but it's everything to the left-hand side is higher than it. So therefore, we are including that turning point. So we write that as being x is less than or equal to 3. X is an element of the set negative infinity, that's circular, up to 3, including the 3, so therefore square bracket. And finally, E, that should be an E there, where is the y dx equal to 0? So where is the gradient equal to 0? And that's exactly at x equaling 3. Again, guys, really important that you understand that there's a difference between talking about the gradient and the strictly increasing, decreasing scenario.